Next, we're down to client-side controls, so let's start with that. I got slides here, although it's mostly going to be demos, actually, as you'll see. All right, so the problem here is that the browser stores data like cookies, and then it sends it back to the server. And it's very common for web developers to send data to the client and then have it come back later and trust that that data has not been modified. But of course, the client could have modified it, and that's a problem. Now, the reason this happens is because it's just more convenient for an app to bounce it off the client frequently than to figure out a channel to move from one server to another at your app farm. This is the problem. Your web page is actually using many different components and many different servers, and often just putting something in a cookie and hoping it'll come back unchanged is the easiest way to do it, rather than figuring out how to move things around between your servers with API calls or something. So, some examples of how this fails. So if you look here, I made a page that's going to demonstrate a bunch of these flaws. So here you buy an iPhone. So if you put in one and submit, you buy an iPhone for $449. The problem is they controlled the price from the client side. So if you go to the proxy, I'm going to clear the history, and then do that again. Let's go back and buy one phone. Okay, I bought a phone. Now the problem is this price for $449 actually came from this page. It is a hidden field on this page. And you can see it here. If you look at the structure of this, I'm going to send it to the repeater. So now it sends up, here's all the usual headers, and in the content, it's sending quantity and price. There is a hidden field in the HTML, which it always says $449 for the price, and you can't modify it. But if you use burp, of course, you can modify it, because the HTML doesn't let you modify it, but the network traffic going over the network is now out of the browser, so HTML doesn't matter anymore. I can change the price, and when I send it, if the server believes that, it will let me buy the phone for $4. Now, the server shouldn't trust anything that came from the client. It shouldn't trust the price that came from the client. It should just have like a product ID number, and then it should look up the price on the server in some database, but it didn't do that. It believed the data that came from the client. And if you look at the HTML of the page, inspect should probably do it. Yeah, here's the page, hidden fields, and you see here, buy an iPhone, price. Here's the form, and so the form has quantity, and this is just type equals hidden. The price is just there with the number, so you can't click in the browser and type in another number, and that's probably why the developer would believe, well, they can't change the price, because they can't change it right here on the page, but if they use a proxy, they can change the price, and that's going to be the case with all these things. So here's a cookie discount. So if you, let me clear the old stuff from the proxy, clear history. All right, so if I click this to get a discount, now I get a discount of 10, so I buy one, and now it's, I got a discount of 10, but I want the discount to be bigger, so I take a look at this, and here is where it sets the cookie, and here is where it posts something. So if you look at the method that set the cookie, let me get this up here so we can see it, all right, and close this. All right, so here's the get that sets a cookie, and so the response here sets a cookie, discount equals 10. Then when you buy later here with the post, it sends up, the request will send up that cookie. There, cookie, discount 10. So it's pretty obvious what to do. You send this to the repeater, and it's sending up to the server a cookie of 10, and I can just change that. I'll tell it my discount should be 100, and send that, and now I get a phone with a discount of 100. So, you know, the usual. These are all very simple variations on the same theme. All right, so let's go back here. Here's URL parameters, so I'm going to buy it here, 1, and send it up. And now, take a look up here. They put the quantity and the price right there in the URL. So you don't even need burp. You can just change the price right there. And now you get a phone for $4. You're all over. And here's one to refer. You can buy a phone, but only from apple.com. So if I submit, it says, nope, you didn't come from apple.com. But you can fix that, of course, if you go to Burp History and find that one, which is the last one here. Send it to the repeater. The way it's telling whether you came from apple.com is from the referrer. So all you have to do is change this referrer to apple.com. And since, again, they're believing something that came from the client, it's in the header, and that changes the results. Now you're able to buy the phone from apple.com. This is all fundamental flaws of believing data that came from the client. Here you have a link limit. So how many can you buy? I'm going to try to buy 22. Well, I can only put in one character. And that's because if you look at the structure of the page, here's the form, and it just has max length equals 1 as a parameter on the quantity field. So you can only put in one digit. But of course, that affects the HTML here. But if I just send one, so I'm buying one phone, then I go to the proxy, and I can modify that request. Send it to the repeater. And here, the quantity is down here, so I can make it 100. Even though I couldn't type that into the web form, I can change it here, and now I'm buying 100 phones. So, many ways to do it. And here, the script-based validation, so the maximum is 5. So if I try to buy 5, it works. If I try to buy 6, it pops up a box saying quantity too large. So the way this works, if you view the page source, this is very, I don't want to do page source, really, I just want to do inspect. All right. So here, this is a really common technique. So there's a form, and on submit, it calls something that says validate this form. Oh, I tried to close a pane, but I got the whole thing somehow. Inspect. There. Here's the form. And so on submit, return validate form. I would like to scroll to the right, but somehow I can't. So it's going to run a script called validate form, and that script is going to be way at the top of the page, probably in the header. Yep, there's the script. Validate form. That's going to check to see if quantity is 5 and give you an error message and not send the script up. Now you could just turn off JavaScript in your browser and that would stop it. You could modify this script, or you can just use your Burp. So when I submit this thing with 5 and then go look to see the request that did that in the proxy, that'll be here. And I can probably tell, because I should be able to tell from the request, this is the one that tried to buy 5. And the script was HTML in my browser that wouldn't let me put in a bigger number, but now I'm outside the browser, so I can just modify this by sending it to the repeater. And now I can make it 55. And there, I bought 55 phones. So they're all minor variations on the same thing. And there's a disabled field, right? You can do this. You can have I can change the quantity here, but I can't change the price. It's disabled. And if you look at the HTML code for that, it's here. It's input type equals text, and the other one is price disabled equals true. You just put it there, and this is what it looks like. You can see it, and it's a number, and it's going to go to the server, but you can't change it by clicking in the browser. But of course, if you send it to the server, it sends the same kind of request, which you can see here in the proxy. And if you send it to the repeater, you'll see, again, the quantity is here. So now notice the price was not sent to the server. This one's a little sneakier. The price is apparently on the server, but it did not send the price. But maybe it would listen if you put it in. You can add it. And price equals 4. And if the server will fall for it. So even though the form disabled the price field and didn't send it up, the server is still listening in case the price comes up. So that's another kind of flaw. And the last one is, if you want to really have fun with all of these, you can enable all the hidden fields in Burp. If you go to response modification in the proxy, and go to proxy settings, down here, you can do response modification. And you can unhide hidden form fields, enable disabled form fields, remove input length limits, remove JavaScript form validation, and so on. Because you're going to make a request to load the page, and it can modify the HTML on the way down for you. So now, if I just go back to here, and I just refresh this page, now it puts the price right there where I can change it. It puts this parameter right there where I can change it. The length limit is gone. I can now put in a bigger number. The script validation will just not run. I can just put in a bigger number, and it accepts it. And the disabled field is now enabled. So that's a real handy way to disable all the client-side validation with Burp. And so that's a demonstration of why the developer should never believe that client-side validation happened correctly. You can do it to create a better experience for the client, to make your page more responsive, but you have to do it again on the server. You cannot trust that any of the code you put on the client actually ran and did what you expected it to do. All right. And so we've done all these. Refer, header. Now, you might have opaque data. There are fields where instead of just having a cookie right there that says like price 10, you just have pricing token, which is a long random hexadecimal blob. Now, this might be better. Certainly, you can't easily change it or read it. It's some kind of opaque stuff. But if you know the plain text, you might be able to deduce it. If something you were able to put in, like your name is encrypted or something, then you can maybe see what it is. I've done this before, where Stitcher. I tested the Stitcher app years ago, and I put in a password of A, and it sent a really short encrypted mess, and then I put in 2 A's and 3 A's, and it was getting longer and longer. It was just using a variant of the Caesar cipher. That's a clue. And sometimes you can replay the opaque text without deciphering it. Just replay it into another location and use it, even if you can't break it. You can try long values, different character sets, malformed strings, and such to see if you can trick the encryption algorithm into failing. And there is, if you have a Microsoft server, you can use ASP. It has this thing called view state, which is Microsoft's competitor for Java encoding. And so you make this thing called a view state, you add the price into it, and now on the server, it will look like this. View state equals just this blob of base64 stuff. So it's not easy for the user to, and the idea is to make it so you can trust data that came from the user, because it has to be serialized into this blob. Now the problem is, all it is base64 encoded. It's not encrypted or anything. So you can just decode it, and you can do that in Burp. Burp has a decoder tab. So you can decode it, and you'll see price is 39. So, and you could modify it and re-base64 and send it up. Now, therefore, there are some apps that turn on MAC protection. So it has this base64 encoded stuff, and then it has a message authentication code at the end. And that's good because that is using hashing and encryption with a secret. So if you want to change the price, you cannot generate the right MAC to go with it. So if the server verifies the MAC, it will notice this data has been modified. And that's what you have to do. If you actually want to send data to the client and then trust it when it comes back, you're going to have to add some kind of cryptographic protection to it so you can make sure it has not been modified by a client. And there are decoders available for to see view state in various ways. This was view state without MAC. So you can put a extension in your Burp. I think it's an extension, might be built in. And then you can just see the contents in there and modify it in a nice graphic environment. We've already seen these length limit. And by the way, sometimes when you fetch a page from the server, you won't get the page. You'll just get not modified. That's because the browser has cached it, and that's controlled with your browser request. It's going to say, if modified since here, then send me the page. Otherwise, don't send me the page because I have a copy from this date. So that's an issue. And if you really want to refresh the page, you can use Shift Refresh, or you can use Burp to remove those headers. So your request no longer says, don't tell me if the page hasn't changed lately. And then there's script-based validation. We just looked at this. And again, you can defeat it with Burp by modifying the data after the script is run, or you can turn off the JavaScript. All right. So The point of JavaScript used for input validation is just to make it easier for the user. If the user is supposed to type in a name and address and a phone number, then if they type in something other than the right number of digits in the phone number, you just reject it. And that's not to protect your server. That's just to make the client have a better experience. Now, if they make an error, it'll tell you right away, you need to fill in the phone number. It doesn't talk to the server at all about that. It doesn't bother sending anything to the server until you have the fields filled out right. It's just a convenience for the user. It doesn't prove, it's not a security measure. It's just a convenience feature. So that's the game. All right. There's the disabled field. We saw that. You can add it anyway. And we saw the response modification. It just makes everything easy to see and easy to hack. So let's try a Kahoot. I've got them here. Should be in my favorites to make it easier to find. There we go, 129S5A. See the code. It's 448320. Last digit is 0. Oh, the box from my camera is blocking the code. I can't see it. All right. Thanks for telling me. I can't see it here. Oh, I could have seen it by looking up there. Okay, I'm catching on. All right. All right. Good. Thank you for telling me. Problem with this amateur home video, I don't have a monitor that can see and hear what you're seeing and hearing. So, although I remember I can see it if I remember to look at it. All right. Let's give it a shot. All right, so why do web apps send data to the user and then expect the user to send it back? That's the point. If you have multiple servers, that's often a convenient way to move information from one server to another. All right. Which one is easy for the end user to modify without using burp? The URL parameter is just right there. The rest of these you'd have to use burp for. You can actually modify them to some extent even in your browser with developer tools, but burp is better. All right, what do you do to make a compressed HTTP response readable? This is in the slide, so I didn't mention it, but that's it. Accept encoding tells the server in your request that it's okay to zip it. And sometimes the server will zip it. And then you'd have to unzip it at the other end. So removing this parameter will send it to you in plain text. All right, how do you completely reload a page in Firefox? All right, shift refresh. Good. Go back to here. All right. And so now you can have browser extensions, although I don't think many people are using them anymore. Flash or Java on the client side. In principle, those also have user scripts and things to be modified. So if you had something like Casino app running in Java or Flash, then the user could tamper with the game. And it's pretty common. There are a lot of cases of people cheating on online gambling games. So Java, Flash, and Silverlight, all these are almost extinct. I think Silverlight has been abandoned by Microsoft. I haven't seen Flash in years, although Java applets, I suppose, may still exist, but I almost never see them used in normal consumers anymore. So they all compile to bytecode, run in a virtual machine, and may use remoting frameworks with serialization. Java applets run in the Java virtual machine, and although I don't see this very often in normal web pages anymore, it is the way Android apps work. So Java serialization, you'd tell it you'll take Java serialized objects, and then it will take a bunch of data, just like ASP view state, which is Microsoft's imitation of this technology, and it will send it to you. So down here you'll see it will send you just a blob of data. This binary-looking garbage, and then it'll unpack it with a tool to show you what's in here. Different users, a list of users and such, hash map and such. So that's all it is. It's essentially the same thing as view state. So make sure your proxy is intercepting traffic if you want to, and then use a serialization unpacker. There are unpackers for all the different forms of serialization available. And then review responses that trigger client-side logic. You might be able to figure out what's going on, even if you can't unpack everything in there. You can look at correlations between these items, that sort of thing, to figure out what message from the server had an effect. And then you can use it even if you can't unpack it. And you can see an example of obfuscation in Android apps here. So I went to the Bank of America Android app. I pull it from the phone with Android Debug Bridge, then unpack it, and when you look at it, the unpacked file has a bunch of these Smalley things. Smalley is the language of compiled Java code. So you see I've got authorization activities, enrollments, and down here I've got business credit card details activity.smalley. So that's pretty interesting. That would suggest that the credit card is handled there. So if I look inside there, the Java looks like this. You have parameters put, username, and password, and after compiling it, it turns into this, which is almost as easy to read. Parameter P3 is username, P4 is password. They're both strings. So this is something many developers don't understand. Java-based apps like Android apps are distributed, for all intents and purposes, with the source code. The code that's actually used and run is very easy to read and modify. So you can modify that code. You can change the locals up here to make room for more variables, and now you can add Trojan code that will take a copy of the card number and put it in the log. And that's what this does. So I was able to take the code, the card number, and the CVV, the 3-digit verification value, and put them in a log. You pack and sign the modified app, and if you can trick somebody into putting the modified app on your phone, it will still work. It will still talk to the Bank of America servers, and when you log in with your credit card number and PIN, it will put them in the log where they can be stolen by other apps, at least on older versions of Android. So this is an example of the most common vulnerability for Android apps, which is that they're not protected against code modification. They could be protected. If you try this with the NFL app, it will not work, because the first thing it does is it verifies that the app has not been modified by looking at hash value. If you try this, it will just pop up and say, your app is out of date. You must update before you can use it. And I don't know why important companies like banks don't use that defense. Anyway, they also use no obfuscation here. So you see all these meaningful names for folders containing all the code, like PayPal and abstractions and controls and data. There's no need for that. You can obfuscate it. You can get ProGuard is a free obfuscator that comes from Google, and if you use that, it replaces a bunch of these names with just A, B, C, D, E, F, G. The problem is a lot of things are still left readable, and everything that seems important seems to be not obfuscated. I've never had trouble hacking into an app that was obfuscated with ProGuard. I could still find a variable named like password or credit card number and things like that. There are more powerful obfuscators like -O, but they cost money. Anyway, so to handle client-side data securely, don't send any critical data like prices from the client. Instead, send the product ID up and look up the price on the server. Now, you might want to display the price in the client's browser so they can see the price, but you don't trust it. You look it up again on the server. If you have to send important data from the client, you're going to have to use cryptography. Sign or encrypt it so that it can't be tampered with. And even if you do that, they still might be able to do replay attacks, where they can just take that blob of encrypted stuff and resend it later in a different context where it may have a different meaning. So even this is somewhat risky, but it's a lot better to do that than to send plain text and trust it not to change. So any client-side validation that you do is vulnerable. You may be useful to give the user a better experience for performance, but you can't trust that it has been done, like a length limit, a price limit, something like that. And logs and alerts, your server side should be aware of the client-side validation, and if you get data from the client that has been modified and doesn't pass your validation, then you know they're not a legitimate customer trying to buy your product. They are a hacker trying to hack into your server. So the logical thing is you should log that, you maybe terminate their session, maybe suspend the account. You should recognize that as a malicious act and that this is a suspicious client. It's doing things that no client should be able to do. Therefore, they're an evil attacker attacking us. And you shouldn't just ignore that. You should take some kind of action, like terminate the session. All right. Let's take a look at the other Kahoot, which is here. All right. Now you can see the number. Good. Everybody that's coming. Hey, that's the wrong Kahoot. Forget that one. 129S 5B is what we want. Let's try that again. That was the wrong class and everything. All right. All right, that's the right class this time. All right, which one of these is not compiled to bytecode? HTML, it's not a programming language. It's just a markup language, and your browser renders it as it is. It's never compiled at all. It does not contain instructions that are processed by the processor. It just contains descriptions of how to draw the page for the browser. All right, so what should you do with received data that violates client-side validation rules? As we're talking about these, using it as is what my demonstration page did. You could modify it and it would just use it. That's the worst. Sanitizing it and using it is something some people like to do. They just clean it up and use it, which is, that prevents it from having the result that you're prepared for, but it often means the attacker is going to be able to find some way to get through. Making the user re-enter it is not necessarily bad, but since you violated the validation rules, the user didn't mistype something, they defeated the functionality of the browser, so they're clearly malicious. So the best, most logical thing is terminate them because they're clearly malicious. All right, so how can you make data from the client trustworthy? Yeah, this is what cryptography is for. Signing it makes it pretty trustworthy. You could perhaps do some things, but you can't modify the data anymore. If you make any modification, the signature won't match. That's the purpose of digital signatures, like MACs, message authentication codes. All right. All right. So that's it for the lecture part. Let me stop the recording.